Hello everyone, welcome to our daily physics problem, day 20. So today we have a mass M and a mass 2 connected by an unstretchable rope carrying on a pulley. If the pulley cannot rotate and the coefficient of friction between the rope and the pulley is mu, write these three expressions that each describes acceleration, t1 and t2. So here the problem is very strange because usually see a pulley problem, pulley is rotating, but here it's not. And usually we have frictionless pulley, but here pulley have a friction. So I want you to pause the video, try your own. After you try it, come back to the video, then I'll show you how I did it. So welcome back guys. So in this problem, because we know that there are friction in the pulley, so that we know the tension of the rope at each segment of the rope of the pulley interval is different. The normal force is different, the friction is different, and the tension is different. So we need to have a microscopic zoom in of the pulley to give up a relationship, figure out the relationship between the angle of the pulley according to the x-axis and the tension and normal force and the friction on it. So we know if we have theta stretch out and d theta, the integration variable, we know that there are four forces acting on it. Normal force, friction force, t theta, and t theta plus d theta. Then let's figure out some geometry. If we connect these two lines, we know this angle have to be d theta divided by 2. Why it have to be true? Well, let's imagine a general case. If we have if d theta is 180 degree, and we have two forces pointing this direction, and we know these have to be 90 degree, and 90 degree is just a half of 180 degree. So in here, the same reason. The open a little angle and we stretch two tangent force out, then the angle in between should be d theta over 2. Then we can balance the force. We know the normal direction, we can write as d theta plus d theta, t theta plus d theta plus t theta, and the sine of d theta by 2 is dn, normal force. In the tangential direction, we know d theta plus d theta minus t theta times cosine d theta divided by 2 plus mu dn equals 0. Then we know when d theta approach to 0, sine of d theta divided by 2 will be approach to d theta over 2, and the cosine theta over 2 will approach 1. The difference between the t theta plus d theta minus t theta will be just the dt, because the increment of t. Then we sum them together, we can approximate as 2t. Then we can rewrite our equation in this following form. First, normal equation, we can write t times d theta equals dn, and dt plus mu dn equal to 0. So we know dt equal to minus mu dn. So here we are trying to balance the force. Imagine the block is not accelerating to find some relationship between the tension force. The tension force, the relationship between the initial and final tension force does not depend on the acceleration. So now we can solve for t. Let's simplify the function, separate the variable, then we integrate it. We got t equal to c, it's a constant, times e to the negative mu theta. Now we know, because actually we can assume that the function is integrating from 0 to pi, because we know the pulley only works when the friction only act on the rope when you are in touch with the pulley, and that only happens from the range from 0 to pi, as here we can show. So and the change of the tension force, which is on the left hand side, will be tension final minus tension initial, and we know that just the T2 will be the smallest force and T1 will be the largest force. So we can write out our expression, T2 equal to T1, e to the minus mu pi. Then by balancing, by laying out the Newton's law for a very classical pulley system, we can try to solve for a T1 and T2. This is from the picture we see this system equation that describe the motion of the blocks and according to the tension. Then we know cancel out the A, we can express this expression as m1g minus t1 divided by m1 equal to t2 minus m2g divided by m2. Then we simplify it. We got 2g will be equal to t1 divided by m1 plus, because t2 we can just plug in t1 times e to the negative mu pi. So we have t2 equal to m1 times e to the negative mu pi divided by m2. Then we factor out t1, we get times this expression, we got 2g. Then we divide by both sides by this messy expression. We got our t1 will be equal to 2g times m1 m2 divided by m2 plus m1 times e to the negative mu pi. Okay, now we solve for t1. That was our first solution. Now let's solve for t2 and a. We know t2 is equal to t1 times e to the negative mu pi. So we know if we multiply both sides by e to the negative mu pi, e to the mu pi, we got t2 times e to the mu pi equal to t1. So all we need to do here to t2 will be just t1 divided by e to the mu pi. And we know the expression for t1, we just divide it by e to the mu pi. We got our solution for t2. Then what is our acceleration of the blocks? Let's just grab an equation or system equation and plug in t2 to try to solve it. Then we know t2 is equal to this, plug in, minus m2g divided by m2 will be equal to a. Then our acceleration, simplify the equation, we have 2 times g m1 divided by m2 e to the mu pi plus m1 minus g equal to a. Then we factor out the g, and then common denominating the denominator, we got 2 times m1 minus m2 e mu pi minus m1 divided by m2 e mu pi plus m1 equal to a. Then we finally get a solution equal to a equal to m1 minus m2 e to the mu pi divided by m1 plus m2 e to the mu pi. That's our final solution. Thank you for today.